Hello and welcome to Lesson 3.3, Measures of Central Tendency. The three measures of central tendency that we're going to look at today are the mean, median, and mode. To begin with, we're going to look at the mean first. The mean is the sum of the data values divided by the number of data values. So what that means is we are actually going to add up all of the data points. So you can see here I have an example. It's the 2, 3, 4, 5, 8, 8, and 12. These are all our data values. If we go and we find the sum by adding these up, we end up with 2 plus 3 plus 4 plus 5 plus 8 plus 8 plus 12. So I just added up all the data values. Now I'm going to divide that by the number of data values. So I've got 1, 2, 3, 4, 5, 6, 7 data values. So I'll come up here and I'll divide that by the number 7. When I go through and simplify, I end up with 42 divided by 7, or a mean equal to 6. The next measure of central tendency that we're going to look at is called the median. The median is the middle number when the data values are written in order. Okay, and the next key piece is when it's an odd number. Okay, so we have an odd number of data values. If we have an even number of data values, then we're going to have to do something slightly different. We can't just take the middle number. For even number of data values, the median is going to be the average or the mean of the two middle numbers. So I'll literally have to add them two together and divide by 2. But as you can see here, we have an odd number. We've got 1, 2, 3, 4, 5, 6, 7 data values. So what that tells me is that our median will be the middle number. So 7, that means I can have 3 on either side of the median. So I've got 1, 2, 3. This is my middle number. And then I got 3 on the other side of that. So you can see that 5 is going to be the middle value, or the median. Another thing that I would like to suggest is when you're dealing with measures of central tendency, oftentimes the first thing I will do is, if my data set is not written in order from least to greatest, is I will go ahead and do that first thing, because it does make things a little bit easier when you're trying to calculate the median or our next measure of central tendency. The third and final measure of central tendency is called the mode. Now the mode is just the number or the data item that occurs the most frequently. So the thing with mode is there can be one mode, there can be more than one mode, or there can be no modes at all, meaning that there's no number or data value that repeats itself more than once. So if you look at our data set that we've been dealing with here, okay, I've only got one number 2, one number 3, one number 4, one number 5, but I have 2 number 8s and only one number 12. So in this case, 8 is going to be the mode, because this is what number occurs the most frequently. Sometimes when we're looking at measures of central tendency or data values in general, there's a few additional things we like to look at. One of those things is called the range. Now the range is going to be the difference between the greatest and the least values. So here, if I want to find my range, I'm going to take 12 and I'm going to subtract 2, because 12 is my greatest value right here, and 2 is my least value. And again, it's easy to find because my data set is written from least to greatest. So 12 minus 2 then is going to be 10. So I can see that all 7 data points fall within a 10 number range. Another thing that is sometimes good to look at when you're dealing with data points is what we call an outlier. An outlier is a data value or values that is much greater than or less than the other data values. And the reason this is important to look at is because sometimes outliers can affect the average or the mean of your group. If you look at the data set that I have listed below, you'll see that we have 4, 7, 10, 11, 12, and 33. So I would say that our data from 4 to 12 is all relatively consistent. You have this data point here of 33 that kind of doesn't really fit in with the other numbers. So because of that, we would say that 33 is an outlier. It's the one that kind of doesn't belong. Now that we know what the three measures of central tendency are, you sometimes have to figure out which one is best to use when you're trying to represent your data. And the way you pick that is you want to pick the one that best represents your information in a fair and accurate way. So for example, the mean. The mean is good when you're trying to represent data that doesn't have any big outliers, because the mean can be affected by those outliers. The median is better to be used when you do have outliers, because you're going to kind of look around that middle number. Likewise, the mode usually is best to use this one when you have no data that is numerical. So in other words, if you take a class poll on what somebody's favorite color is, and let's say blue occurs the most frequently, it's probably going to be best to use the mode for that because you can't put a numerical value to that. When I look at test scores, okay, if I have a class of 20 people and I have 3 students that are absent and we temporarily put zeros in for those absent students, those are going to be 3 outliers to test data. So I might look at the mean just to see kind of what the class average is, but for the most part, the median is going to have a better representation because those zeros are going to be pulling that mean down. Now it's time to look at example 1. Example 1 says, what is the mean number of grams of fat in a 2 tablespoon serving of the mixture of nuts that we have here based on this table? So again, to find the mean, we are going to add up all the numbers and divide by the total data points that there are. So if we go to look at grams of fat, I can see that this column right here is the one that I'm looking at. So if I take those and I take 8.9 and I add that to 9.1 and we add that to 7.9 and another 7.9 and another 8.9. Oops. And another 7.7, or a 7.7 rather. Okay, if we add all of those up and divide by the total number of data points, well, there's 1, 2, 3, 4, 5, 6 data points. So I'm going to go and divide by the number 6. And when I do that, I end up with an average or mean of 8.4. Okay. Likewise, for part B, it says, what is the mean number of calories in a 2 tablespoon serving of the mixture? So again, I'm going to add up all of the calories. So 104 plus 90 plus 92 plus 93 plus 102 plus 80, and we know that there are 6 data points, so we're going to divide that by 6, and when we do that, we end up with an average of 93.5 calories. So 93.5 calories is our mean or average number. Now for example 2, we're going to look at outliers. Part A says which data value is an outlier when we're looking at the approximate land areas of Central America. So again, if you list these out, sometimes I think it just helps if we put them in order. So we're going to start out with 200 square miles. Then it looks like our next biggest one is 1,200 square miles. Then we're going to go looking at Panama. That's 2,100 square miles. Then we have El Salvador at 2,200 square miles. And then it looks like we go to Nicaragua, which is 4,500. Then we have Guatemala at 5,000. And last but not least, we'll have Honduras at 6,500. So these are all of our data points written from least to greatest. Now with an outlier, we're typically looking to see either something that's really, really small or really, really big. So you kind of want to look on your outside edges. So to see which one is the outlier, okay, I'm going to come and look at the difference between 200 and 1,200. So this right here is going to give us about, if I look at the difference between these two, this is going to give me a difference of about 1,000. Okay, to where if I come and I look at my two end values, this is going to give us a difference of about 1,500. So since 1,500 is greater than 1,000, we're going to consider the 6,500 square miles, which is Honduras, as the outlier. So this right here is our outlier. Part B wants us to find out how the outlier affects the mean. So to do this, what we're going to do is we're going to look at the mean with the outlier. And I'm going to just put with in parentheses, or W for with. So if I calculate the mean with the outlier, I'm going to go 200 plus 1,200 plus 2,100 plus 2,200 plus 4,500 plus 5,000 plus 6,500, and we're going to divide this all by 7 because there are 7 data points. So if I add those all up and divide by 7, this gives me an average or mean of 3,100 square miles on average. Now let's look at the average if we take out the outlier of 6,500. So I'm still going to go through the same process. I have 200 plus 1,200 plus 2,100 plus 2,200 plus 4,500 plus 5,000, and again I'm going to leave out the 6,500 because this is our mean, and I'm going to put WO for without the outlier. And because I took that outlier out, I am now going to divide by 6 data points. So when we add up the numerator and divide by 6, we get 2,500 square miles. So now if I want to look at the difference that gave me in my outlier, if I take that 3,100 that I originally found when I had the outlier, and I look at my calculation of the average when I took the outlier out, that's 2,500. When I subtract these, I get a 600 square mile difference. So just by keeping that outlier point in there, that's going to shift my data upwards by about 600 square miles. For our last example, we have to find the mean, median, and mode of the data set and decide which is the best measure of central tendency to use. Now the nice thing is if you look at our data here, it does happen to go in order from smallest to largest. So I'm not going to rearrange that. We're just going to let that stay like that. But I am going to go and I'm going to try to find the mean. So the mean, we're going to find by going 5.5 plus 5.5 plus 5.5 plus $6 plus $6.20 plus $6.30 plus $8 plus 17. We are going to add them all up, and then we are going to divide everything by, it looks like there's 8 data points. And when we calculate that, I get a mean of $7.50. There's a decimal right there. Next, I want to look at the median. Well, the median is going to be the middle number. So if I look at all my data, I have 8 data points over here. I've got 4 in this column, 4 in this column. So that tells me that I'm going to have to find the average or the mean of the 2 middle numbers. So for the median, I'm just going to write MED for the median. I have 6 and I have 6.2, which are going to be the 2 middle numbers. So I have to find the average or mean of those 2 numbers. So if I go 6 plus 6.2 and I divide these by 2, I end up with 12.2 divided by 2, which is going to give me $6.10 as my median value. And last but not least, we have our mode. Remember, mode is the number that occurs the most often. Okay, so looking at our data set, I can see that we have 3 numbers over here that repeat themselves, and those are the only 3 numbers that repeat themselves. So here, our mode is going to be $5.50. Next, we have to figure out which measure of central tendency would be best to use for this data set. Okay, so if we go through and we kind of look at these logically, okay, the mean or the average, okay, the problem with the average is that we do have an outlier. Remember, outliers are the numbers that kind of don't fit in with the rest of the data. And I would say that that outlier is the number 17. Okay, all my other numbers fall between $5.50 and $8, and then I have this one number that pops out at 17. So mean probably isn't going to be the best number because you have that outlier of 17. When I look at the median, a median is going to be better because I do have an outlier. And then the mode, when you look at the mode isn't a great representation of this set of data because it's the bottom number of all of the data. And we want something that kind of best represents all of the data. So at this point in time, I would say your median is going to be the best representation for this set of data. Now this wraps up lesson 3.3. If you guys have any questions, please do not hesitate to send me an email. I will be checking them periodically throughout the day. Thanks and have a great day.